Welcome back to another video. In this video, we are going to talk about how to factor using the difference of squares. We have been going through this TSI prep video, and I just want to remind you to just hang in there. We're almost through. We're going through the material. You can do this. Stay focused. Don't give up. Don't quit. All right. So we're going to talk about factoring. And the first thing we're going to talk about with factoring is the first step of it is to look to see if there is a greatest common factor. And that's what we talked about in the last video, how to pull out the greatest common factor, the GCF. The second thing you want to do is you want to count the number of terms. If you have two terms, then the thing you want to check for is the difference of squares. First of all, what does difference mean? Difference means subtraction. So if you have two terms, and you want to first look to see, is it a subtraction between the two terms? If it's not a subtraction and it's two terms, and you can't pull out a GCF, then you can't factor it, all right? Another thing we want to talk about is, well, first let's look and see what does it look like. All right, so if you have something squared minus something squared, so say a squared minus b squared, then that will factor into the first term plus the second term minus the first term, or the first term minus the second term. All right, so if you have a squared minus b squared, something squared minus something squared, then that equals that first thing that you squared plus the second thing that you squared, and that first thing that you squared minus the second thing that you squared, and that will always work. And let me show you why that will work. Factoring is the opposite of multiplication. So if you want to check your factors, then you just multiply to check it. So I'm going to multiply the right side of this, the a plus b times the a minus b, using the box method. So I'm going to put a plus b along the top, a minus b along the side, and I'm going to multiply what's on the side and what's on top. So a times a is a squared. A times b is ab. Negative b times a is negative ab, and negative b times b is negative b squared. And so that ends up giving me a squared plus ab minus ab minus b squared. And look, the AB's cancel. That's a positive AB and a negative AB. And that leaves you with a squared minus b squared. And that's just showing you why a squared minus b squared factors into a plus b, a minus b. And that's going to happen every time. So before we jump into some examples, let's talk about what your perfect squares are. So what are perfect squares? Your perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, and you can keep going. You want to know how I'm getting these? If you said squaring the integers, then you are correct. 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared, 36 is 6 squared, 49 is 7 squared, and 64 is 8 squared, and you can keep going. You can square 9, you can square 10, you can square 11, and so forth. Those are your perfect squares, and these are the numbers that you want to look to see if you have when you're trying to factor the difference of squares, because you're really factoring the difference of perfect squares, all right? So now let's look at some examples. For this first example, we're going to factor x squared minus 25. And the first thing you want to do is look to see if there is a greatest common factor. Both of these terms do not have an x in it, so I can't pull out of x. And because there is no number in front of x squared, there's an understood 1 right there. And 1 is prime, meaning it has its only factors are itself. So the only numbers that multiply to give you 1 are 1 and 1. So there are no numbers that you can pull out of both terms. So in this case, there is no greatest common factor. So the next thing you want to do is you want to count the number of terms. In this case, there are 2 terms. If there's 2 terms, the only thing you could check for is the difference of squares. So is this a difference? Yes, it is a difference, meaning there is subtraction between the two. So then the last thing I want to do is I want to ask myself, can I rewrite x squared as something squared? And can I rewrite 25 as something squared? Well, x squared is just x squared. 25 is a perfect square. If you remember from our perfect squares earlier, 25 is 5 squared. So since I can rewrite the first term as something squared and the second term as something squared, then this is the difference of 2 squares, and it will factor into x plus 5 times x minus 5. And so that's how you factor it. If you want to check it, you can multiply that out. When you multiply it out, it will give you x squared minus 25, and that's just to check it, okay? That is how you would factor x squared minus 25. Let's look at another example. For this second example, we're going to factor 9y squared minus 16. The first thing we want to do is we want to see if there's a greatest common factor, where your only factors of 9 are 1, 3, and 9. And 3 or 9 don't go into 16. 1 do, but you don't pull out a 1. So you can't pull out a number from both of those terms. And then both of those terms don't have a y in it. So you also can't pull out a variable from both of those terms. So in this case, there is no greatest common factor. Now, it's 2 terms, so you want to count the number of terms. It's 2 terms. So when it's 2 terms, you want to check for the difference of squares. So is it a subtraction involved? Yes, there is subtraction. So now you want to ask yourself, can I rewrite 9y squared as something squared? And can I rewrite 16 as something squared? Well, 9 is a perfect square. If you remember earlier, that was 3 squared. And y squared is just y squared. So 9y squared can be written as 3y squared because you square both of the terms. You would square the 3, you get 9. You would square the y, you get y squared. Now, can I rewrite 16 as something squared? 16 was also a perfect square. 16 is 4 squared. So I can rewrite this as the difference of squares. This is 3y squared minus 4 squared. So in this case, since I can rewrite it as the difference of squares, it factors into 3y plus 4 times 3y minus 4. And again, if you wanted to check it, you could multiply that back out using the box method. And when you multiply it back out, you'll get the 9y squared minus 16 that you started with. But this is how you would factor 9y squared minus 16. 3y plus 4, 3y minus 4. Let's look at one more example. All right, in this example, we're going to factor 6y to the 4th minus 6x to the 4th minus 6y to the 4th. Okay, so the first thing we need to do is check to see if there is a greatest common factor in both terms. Well, if you notice, both terms have a 6 in it, so we can indeed pull out a 6. And if we pull out a 6, then we're going to put parentheses and write what's left after pulling out the 6. Now, to figure out what's left after you pull out the 6, before I talk about that, notice that both terms don't have an x in it and both terms don't have a y in it, so I can't pull out a variable. The only thing I can pull out is a 6, all right? So now to figure out what's left inside the parentheses, essentially what you do is divide each of these by 6. And if you divide the first term by 6, you're left with just the x to the 4th. And if you divide the second term by 6, you're left with just a y to the 4th, all right? And so we're not really dividing the whole thing by 6. We're just dividing by 6 to figure out what's left inside those parentheses. So now inside the parentheses, I have 2 terms, and you have to factor completely. So now you have to check to see if this is the difference of squares inside the parentheses. So the question is, can I rewrite x to the 4th as something squared? And can I rewrite y to the 4th as something squared? The answer is yes. X to the 4th can be written as x squared squared. The reason is because with properties of exponents, anytime you have an exponent and you raise it to another exponent, you multiply the exponents. So x squared squared, you will multiply those exponents. 2 times 2 is 4. That's the same as x to the 4th. And you can do the y the same way. Y squared squared is the same as y to the 4th. So this is important because now I've written the inside of that parentheses as the difference of 2 squares. And so it ends up factoring into x squared plus y squared times x squared minus y squared. Now, if you notice, I have another set of parentheses that has 2 terms in it, but also have a subtraction in it. Now, this first set of parentheses, I can't do anything with it because it has an addition. But this one has a subtraction, so that means I need to also check to see if this can be written as the difference of squares. And I'm just going to come over here on the side and rewrite x squared minus y squared. Now, notice that is x squared minus y squared. So that is the difference of 2 squares, and so that factors into x plus y, x minus y. All right, so this is just a little side note over here. And so that means that this x squared minus y squared can be factored into x plus y, x minus y. So I'm going to drop my 6, I'm going to drop my x squared plus y squared, and I'm going to rewrite x squared minus y squared as x plus y, x minus y. Now this is 6x to the 4th minus 6y to the 4th, completely factored, all right? So anytime you have 2 squares, or 2 terms, You always want to check to see if you can factor it using the difference of two squares, all right? So if you haven't already been following along in the free course that I've created, then you need to go ahead and log in and follow along in that course. You can log in completely for free and you can practice everything that we're talking about in these videos, and it will give you immediate feedback, all right? So read the description on how to log into that free course. If you don't understand anything that I say, if you have a question about anything, don't hesitate to put that in the comments as well, and I will respond as soon as I can, all right? Thanks for watching. If these videos are helping you, go ahead and make sure you hit that like and subscribe button, and I will see you in the next video.